Okay, it seems like the flurry of answers coming in for this problem have stopped now, so I'm going to take a moment and go over this. Remember, we're talking about resolving an angled vector, this angled vector here, into its horizontal and vertical components. And I had you try this problem 1-1, and I've given you a couple minutes to send answers in. I told you to make sure you watch your signs. We are going to have, one of these is going to be negative and one's going to be positive, and most people got that correct. You have to also remember your units because we're going to have feet on these vectors. So let's go over how to solve this, and we'll see if you sent me the right answer or not, and you can kind of check along with your work as I do this work. So remember, we're going to break this vector into horizontal and vertical components. I'm going to go ahead and just draw them in here. So my vertical component, if I think I'm starting here and I want to wind up here, I'm going to have to go up. Okay, so my vertical component is going to have to be positive. But if after I go up and I want to wind up over here, let's do the red, I'm going to have to walk along this direction to wind up on my endpoint, so my horizontal component is going to have to be negative. All right, so let's look at the math and see how this breaks down. So I have my 60 feet. Let's find our horizontal component first. My horizontal component is going to be that 60 feet times the cosine of theta, and in this case our theta is 20 degrees, so it's 60 feet times the cosine of 20 degrees. I'll put that into my calculator, and you can do that along too with your calculator. And remember, if you forget your calculator sometime, you know, most cell phones, my cell phone here has a nice calculator I can use. I can take 20 cosine. I just have to turn on its side to do that, and then I'm going to multiply that by my 60 feet. Okay, and we're just going to take this to the tenths place, so I have 56.4. And some of you sent me 56, that's fine, to 56.4 feet. And then for my vertical component, I'm going to take my 60 feet and multiply it by the sine of theta. So I have 60 feet times the sine of 20 degrees. And again, I'm going to use this on my handy dandy cell phone calculator. So I've got 20 sine times 60. And I get this nice long thing. I'm just going to take it to the tenths place, 20.5. So maybe sent me 21, that's fine. So that's 20.5 feet. But before I'm done, I have to check my signs. So I drew it in here on purpose so I would remember that at the end. My horizontal has got to have a negative sign in front of it. Okay, in order to think about the components for this vector, it's going to have to go in that negative direction to get to this location horizontally. So it has to have a minus sign in front of that component. The vertical is positive. You can put the positive sign in front of it if you want to, or just leave it without a sign. It's up to you. But these signs are going to be really important as we're putting components of vectors together to get resultants. We're going to need to make sure we're keeping track of these signs. Units, of course, are always important. I'm not going to trick you out by give you some resultants in inches and feet and make you convert, but I still want you to make sure you're mindful of this and you're putting these in your final answer. So here's what I was looking for a final answer. H equals negative 56.4 feet and V equals 20.5 feet. Let's try another one. Very similar, and I want you again to send me the answer. I'll slide it down here so you can see it, but maybe leave that other one visible. So problem 1, 2, this time I want you to separate this vector into components along the H and V direction. And look at the main difference here is that my angle that's being measured here is off of my vertical component. It's not off my horizontal component. So look back into your notes a little bit and see how we're going to deal with that. Oftentimes, when we have our angle off the horizontal component, we call that angle theta. And when we have our angle off the vertical component, we call that angle phi. So this time we're being given phi and not theta. And that's going to change a little bit things with our cosine and sine. So give that one a shot. Send me your answers in the Q&A, in the private Q&A, and I'll respond to you. And then I'll give you a couple minutes, and then we'll go over the solution. Okay, I'll be back in just a minute.